Good morning, everyone. It's Zhuzhen here. Today, I'm going to deliver a tutorial about thermodynamics in everyday life. Let's begin with the concept of thermodynamics. According to the definition in Wikipedia, thermodynamics is a branch of physics that deals with the heat, work, temperature, and their relations to energy entropy, and the physical properties of matter and radiation. The behavior of these quantities is governed by the four laws of thermodynamics. Some of you might be familiar with four laws of thermodynamics because they are basic concepts in physics. If you don't hear about them or forget them, it's okay. Let's review them together. First one is the zeroth laws of thermodynamics. It defines thermal equilibrium and forms a basis for the definition of temperature. If two systems are each in the thermal equilibrium with the third system, then they are in thermal equilibrium with each other. In simpler terms, this means that if two objects are at the same temperature as the third object, then they are at the same temperature as each other. This might seem like a common sense observation, but it is actually an important principle that analyzes many thermodynamic calculations and experiments. The zeroth law of thermodynamics is called the zeroth law because it was added to the other laws of thermodynamics after the first, second, and the third laws had already been established. Then let me give two simple examples of the zeroth laws of thermodynamics in everyday life. In a cold winter, when you walk into a warm room, you can feel relatively high temperature and sense the heating in the room. This is because your body is in thermal. This is because your body is in thermal equilibrium with the air in the room, and you can sense the temperature of the air. Another example is the refrigerator. When you put a warm drink into the refrigerator, it will eventually cool down to the same temperature as the surrounding air inside the fridge. This is an example of the zeroth laws of thermodynamics, as the drink and the air are in thermal equilibrium with each other. Then let's talk about the most classic law of thermodynamics, the first law of thermodynamics. It states that when energy passes into or out of a system, the system's internal energy changes in accordance with the law of conservation of energy. In simple terms, this means that the total amount of energy in a closed system remains constant, and any energy that is lost by one part of the system must be gained by another system. This first law of thermodynamics is often expressed mathematically as delta U is equal to Q minus W, where delta U is the change in internal energy of the system, Q is the heat added to the system, and W is the work done by the system. The first law of thermodynamics has many important applications in physics and engineering. It is used to analyze and design systems that involve energy transfer, such as engines, power plants, and refrigeration systems. Then let me introduce some examples of the first law of thermodynamics in everyday life. The first one is power generation. As we know, nowadays there are many ways to generate power. The essence of power generation is transfer all kinds of energy to electricity, and the most classic energy form is thermal energy, which mainly comes from fossil fuels. Since the revolution of the industry from the 18th century, people exploit a tremendous amount of fossil fuels. The most used three types of fossil fuels are coal, crude oil, and natural gas. The use of fossil fuels truly brings people numerous productive forces, but also cause a lot of damage to our environment, as we can see in this picture. In the power plant, after the burning of fossil fuels, the fume came out from the chimney continuously. The fume contains a lot of chemical waste, like nitric oxide or sulfur dioxide, which might cause acid rain, which damage our health and our environment. Some of you might hear about the greenhouse effect before. Let me give a brief introduction of greenhouse effect. The greenhouse effect is a natural process that occurs when certain gases in the Earth's atmosphere trap heat from the sun, warming the planet's surface and creating a habitable environment for life. These gases, which include carbon dioxide and methane, are known as greenhouse gases. The greenhouse effect is a good thing because it can protect the Earth, but as these greenhouse gases mainly came from the burning of fossil fuels, while the greenhouse effect is a natural process that can help to create a habitable environment on Earth. Human activities such as burning fossil fuels and deforestation has increased the concentration of greenhouse gases in the atmosphere. This has caused an enhanced greenhouse effect, led to a global warming and climate change. That's why nowadays the reduction of carbon dioxide emissions is very urgent. Many countries and organizations have set targets for reducing carbon dioxide emissions, and there are ongoing efforts to develop new technologies and policies to accelerate the transition to a low-carbon economy. Considering the use of fossil fuels pollutes the environment severely, people try to find other kinds of energy source. For example, the solar power is very clean. We can see the solar panel everywhere, which can transform light energy to electricity. That is the hydropower. We can see in this picture is the Three Gorges Dam in Hubei province, which provides a huge amount of electricity every year. Then is the wind power. We can see the fans in the picture. They can transform wind energy to electricity. In some countries like Netherlands, wind power takes the main portion of power generation because of their abundant wind energy. And then is the nuclear power. Nuclear power plants produce a lot of energy from a relatively small amount of fuel, making them a potentially efficient and cost-effective energy source. But on the other hand, nuclear power plants have the potential to cause accidents such as Chernobyl and Fukushima disasters, which can have serious environmental and health impacts. The figure shows the electricity generation of China by fuel type. We can see the burning of fossil type is still the main energy source in the 21st century, but it's worthy noting that other kinds of energy source, especially the hydropower, gradually increase with time passing by. In the future, if someone of you want to choose to academics, the development of new energy might be a good choice. Then let me talk about other applications of first law of thermodynamics. In our body, there exists a very complicated digestive system. When we take food, the chemical energy stored in the food is transformed to heat, which can keep the balance of our body temperature and ATP and ATP. ATP is a molecule that serves as a primary energy source for many cellular processes in human body. ATP is produced in the cells through the process of cellular respiration and then used to power a variety of biological reactions. We can also call them metabolism. Another example is photosynthesis. As humans, we can't absorb the solar energy directly. However, the plant can make it. Here is the equation of photosynthesis. Carbon dioxide and water in the mesophyll cells, which with the existence of sunshine, they can be transformed to oxygen and glucose. Through this process, solar energy is transformed to chemical energy and stored in plants. Nowadays, scientists are struggling with artificial photosynthesis. Artificial photosynthesis typically involves the use of a device called a photoelectrochemical cell, which consists of a semiconductor material that absorbs sunlight and generates an electric current. This electric current is then used to drive the chemical reaction and that convert carbon dioxide and water into energy-rich molecules. The goal of artificial photosynthesis is to develop a sustainable and renewable source of energy that can help reduce the effects of climate change and the dependence on fossil fuels. Then let me introduce some examples of the second law of thermodynamics in our life. Firstly, let's review the concept of the second law of thermodynamics. The second law of thermodynamics is a fundamental principle of physics that states that the total entropy of a closed system will always increase over time, as you can see in this figure. Heat always flows from the hot object to a cool object until they reach thermal equilibrium. When the temperature of these two objects reaches the same level, we can say they reach thermal equilibrium. Firstly, let's give me two simple examples. When we put some ice in a cup, it would gradually melt and transform to water. And when we open a box filled of gas, it will diffuse to air. During the two processes, the total entropy of the system is always increased over time. Another example is the food spoilage. When you leave food out at room temperature, it will eventually spoil due to the bacterial growth and chemical reactions. This is an example of the second law of thermodynamics, as the food is becoming more dissolved and its energy is being dispersed to the surrounding environment. Here is another example. When you are DIY a beverage or a cocktail, you will add a series of ingredients to change its flavor or its color. However, after you mix them together, it is impossible to extract one ingredient from the mixture because the drink is becoming more dissolved and the entropy is increased spontaneously. Here are another two examples. You can see in this picture, when you place a hot cup of coffee on the table, the heat from the coffee will transfer to the surrounding air and the table, causing the coffee to cool down. This is an example of the second law of thermodynamics, as heat always flows from hot object to cool object until it reaches thermal equilibrium. And here is the last example. As we know, the bulb can convert electricity into light energy, but some of the energy is lost as waste heat due to the second law of thermodynamics. It's inevitable that some energy will be transferred into heat and lost in the environment. So according to the second law of thermodynamics, the energy conversion efficiency of any heat agent is less than 100%. Based on this rule, what we want is developing new technology to increase energy transfer efficiency and decrease consumption of energy. The last one is the third law of thermodynamics. The third law of thermodynamics states that it is impossible to reach absolute zero temperature through a finite number of processes. This means that no matter how much energy is removed from a system, it can never be cooled to absolute zero. The reason for this is that as the system approaches absolute zero, its entropy also approaches zero. At absolute zero, a perfect crystal would have zero entropy and be in the state of maximum order. However, it's impossible to reach the state through a finite number of processes because as the temperature approaches absolute zero, the system becomes increasingly resistant to the further cooling. Then let me introduce one example of the third law of thermodynamics. The superconductor. The third law of thermodynamics sets a limit on how close to absolute zero materials can be cooled. This limit is an important factor in the design of superconductors. Superconductivity is a phenomenon in which certain materials exhibit zero electrical resistance at very low temperatures. However, superconductivity can only occur at temperatures close to absolute zero due to the third law of thermodynamics. And superconductivity has been applied in many aspects, including science, medical, transportation, industrial, and energy. However, nowadays scientists are taking deeper research into superconductivity at room temperature. If you have interest in this topic, you can refer to some reports. Here are my sharing of thermodynamics in everyday life. If you have any question or you want to discuss, please contact me without hesitation. Thanks for your listening.